So we're looking at confidence intervals today. So confidence intervals is the next step that we're looking at in terms of statistics. And what confidence intervals tells us is it gives us a data indication of where information lies between two different points, a lower and an upper. So what is this confidence interval? So the confidence interval is a formula that we use that helps us work out where 95 or 96 or whatever z-score we're looking for of the data would lie between. So generally, this is what the formula itself looks like. Now it does look quite complicated. However, when it comes to looking at the confidence interval, there are really only three different sections that you need. We need to know what your sample mean is. We need to know what your z-score is. Your sample size. And your sample deviation, or your standard deviation. Now when it comes to calculating with the confidence interval, the z-score is always generally going to be the same, which is 95% confidence. So this here represents 95%. So for instance, if we were looking at this in terms of a graph or a bit of data here on the normal distribution curve, what we will notice here is our mean, remembering that we've got 1, 2, and 3 in terms of z-scores. 1, 2, and 3 in z-scores in the opposite direction. We also know that this here would be equal to your mean minus deviation, your mean minus 2 deviations, and your mean minus 3 deviations. Your mean plus deviation, your mean plus 2 deviations, and your mean plus 3 deviations. Now 95% is generally going to be sitting from here to here. And if we're going to work this out and plug this to a calculator to find the z-score, which we are going to do in another video, we'll find that this here is 95%, but at this particular point, just before it reaches 2, it has a z-score of negative 1.92 and positive 1.96. So negative 1.96 and positive 1.96. Hence why we have this information here for our confidence interval. So when it comes to your confidence interval, the three main things that you will need always will be your sample size, your sample mean, and your standard deviation. We can also split this up into different sections where x minus 1.96 deviation of the square root of n is also known part as your lower end, where x plus 1.96 deviation of n is your upper. So essentially what we have here is when we're looking for a confidence interval, we're getting a lower value and an upper value that would be above or below the mean or the midterm. So when you are calculating this kind of data, you'll get something that kind of looks like this, where you'll have A is less than equal to the mean, which is less than equal to B, where this here is your lower, here is your midpoint, for lack of a different word, and then here is your upper. Now this could be a 95% confidence interval, this could be a 98% confidence interval, it could be a 68% confidence interval. No matter what kind of confidence interval it is, it's always going to be written out in the same manner, where you have a lower, you have your mid, you have your upper. One last thing that comes with confidence intervals is the statements that we always must say that describes what this confidence interval here is. So for instance, if we're going to describe this answer here, what we write this here is we say we are 95% confident that the data, or that the data lies within A and B. Now, this here is a generic description of what this is representing. Because I don't have the concept of the question, I'm just writing it as data. So for instance, if you're looking at the weights of cats, you would say we're 95% confident that the weights of cats lie between whatever A and whatever B represents. But the main important part here is confidence intervals lie and relate heavily to the central limit theorem. Okay, so the central limit theorem is the underlying factor that helps you understand the confidence interval. As you can see from the central limit theorem, we have what you call your standard error here. Okay, so it all comes back, and when we start doing some examples in the next video, you'll see those relationships between central limit theorem and the confidence interval, and how they work together to be able to solve solutions using these questions. And we'll do that in the next video. I'll see you then.